In this lesson, we're going to learn how to use graphs to represent and analyze proportional relationships. Remember that a proportion is a statement that two rates or ratios are equal. So for example, write this down with me. If I have 4 to 12, and I'm trying to see if these two ratios, 4 to 12 and 1 to 3, if they form a proportion, they would be equal. I can test it by cross-multiplying, okay? 12 times 1 is 12, and 4 times 3 is 12. And since they're equal, this does form a proportion. Well, let's do an example of two ratios that do not form a proportion. Okay, if I multiply 4 times 15, that would be 60, and 8 times 8 would be 64. Well, because these two products are not equal, this would not form a proportion. So we can use tables and graphs to identify and explore proportional relationships. In the first problem, it says most shower heads that were manufactured before 1994 use 5 gallons of water per minute. Is the relationship between the number of gallons of water and the number of minutes a proportional relationship? So you want to circle, we're going to use our cubes. You want to circle the 5. Okay, we're going to box that it's 5 gallons of water per minute. And the question is the relationship between the number of gallons of water and the number of minutes a proportional relationship? So in order to figure this out, we're going to complete our table. Remember that all the values in your top row, these are your x values. All the values in your bottom row, these are your y values. So it says that each minute 5 gallons of water are used. So for 2 minutes, then we would do 2 times 5, so that would be 10 gallons of water used. In 3 minutes, we would have 15 gallons of water used. So for 35 gallons of water, okay, we would have 7 minutes. And then for 10 minutes, we would have 50 gallons of water used. Okay, based on the table, is this a proportional relationship? Explain your answer. Well, remember what we talked about in the last video, that your constant of proportionality is y over x. If I take these values and I put my y over x to divide, okay, 5 over 1 would equal 5. 10 over 2 would also equal 5. 35 over 7 would also equal 5. Okay, I left out the 15 divided by 3 and the 50 divided by 10, but all the way across it equals 5. So because the constant of proportionality is 5 for the entire table, then this would be a yes, because the number of gallons per minute remains constant, which is equal to 5. For part C, they want us to write the data in our table as ordered pairs. So again, 1, 5, we have 2, 10. Remember, your x value always comes first. 3, your y value comes second. That'd be 15. So 7, 35, and 10, 50. For part D, they want us to plot the ordered pairs. Okay, so we're going to go graph them. Over to the side, remember your x comes first. You go down the hall first, then up the elevator. So we're going to go down to 1, up the elevator to 5, and you're going to put a point there. Then we're going to go down the hall to 2, up to 10. Down the hall to 3, up to 15, down the hall to 7, which is way over here, up the elevator to 35, which is right there, and then the last one is down the hall to 10, up to 50, which is right there. When you connect your dots, remember this line extends in both directions. Okay, I want you to notice that it went through the origin. Okay, so on part E, it's asking if the shower head is used for 0 minutes, how many gallons of water will be used? What ordered pair represents this situation? What is this location called? Well, at 0 gallons, it would have used 0 gallons of water. So that's the first answer, 0 gallons of water. The second question was asking what ordered pair represents this situation. Okay, so that would be 0, 0. And then what is this location called? Again, that is our origin. That's our third answer. Okay. Part F, draw conclusions. If you continued the table to include 23 minutes, would the point 23, 125 be on this graph? Why or why not? Well, in order to find that out, we can multiply 23 times 5. Okay, that'd be 15, 10, 11. So you see that my y value should be 115, and here it's saying that my y value is 125. So does this continue on with the same rate of change? Is it constant? No, it does not match the data in our graph. So we can say no because 23 times 5 only equals 115. Okay, so now you're going to pause your video and you're going to try the your turn by yourself. So pause your video. Okay, let's see how you did. This problem says Jared rents bowling shoes for $6 and pays $5 per bowling game. Graph the data. Is the relationship a proportional relationship? Explain. Okay, this is your X, this is your Y. We're going to go ahead and graph our ordered pairs. So 111 would be about right there. And then 216 would be here. And 321 would be about here. And 426 would be about right there. When I connect my dots, okay, notice that it did not pass through the origin. So is this a proportional relationship? We would say no. The line does not pass through the origin. Okay, you can also find this out by checking if if they have the same rate of change, the same constant of proportionality. So remember that k equals y over x. So if I go 11 over 1, that's 11. If I go 16 over 2, you can see that that equals 8. 21 over 3, that equals 7. And, well, 26 over 4, it's going to be a decimal, but you could already tell that these are not remaining constant. So that's how you know that it is not a proportional relationship, and because it doesn't pass through the origin. Okay, flip your notes over. On this side, we are going to be analyzing graphs. Okay, recall that you can describe a proportional relationship with the equation y equals kx. The constant of proportionality k tells you how steep the graph of the relationship is. The greater the absolute value of k, the steeper the line. Remember what absolute value means? It's the distance away from 0. So a number like negative 10, how far away is negative 10 from 0? It's 10 away. Okay, this has a greater absolute value. So if these two constant of proportionalities were being compared, this graph would be steeper. That's all it's saying here. Okay, in example 2, the graph shows the relationship between time in minutes and the number of miles Damon runs. Write an equation for this relationship. Okay, so we see that if we look at our x and our y, Okay, for every 10 minutes, he runs 1 mile. So we're going to put 10 comma 1, and we're going to go ahead and write that out, okay, because it's asking what the point represents. It represents for every 10 minutes, Damon runs 1 mile. Okay, let's go ahead and connect our points here. Okay, what is the constant of proportionality? Well, we're going to go ahead and make a table. They did not make one for us. So we have our x and our y values. Our x-axis, remember that's our independent variable, is your time in minutes. And our y is our distance in miles. Okay, so this table doesn't have to be perfect, but we know that for 10 minutes he runs 1 mile. For 2 minutes, okay, you could see that in not 2 minutes, 20 minutes. In 20 minutes, he runs 2 miles. So in 30 minutes, he runs 3 miles. And you could keep going. But here, it actually has in 25 minutes, that's where the next point is, he runs 2.5 miles. And then I should have put the 30 and the 3 over here. My bad. We're just going to scratch that out. Okay, so it's asking for the constant of proportionality. Again, if I go divide my y by my x, okay, remember you have to divide y by x. That is 1 divided by 10, okay, and then 2 divided by 20, which would simplify to 1 over 10. And then 2.5 divided by 25, which would also simplify to 1/10. And the same with 3 divided by 30 would also simplify to 1/10. So my k, my constant of proportionality, is going to be 1 over 10. Step 3, write an equation in the form y equals kx. Well, y equals, my k is 1/10 x. That's all you would have to write for that. Okay, now I'm actually going to have you stop the video and you're going to do the your turn. I want you to do 1 and 2 on the your turn, and we're going to go over these answers in class tomorrow to make sure you are understanding this lesson. See you tomorrow.